Okay, I think we can start now. So, first of all, good morning, afternoon, evening, everyone with his own time zone. I'm Wisam Jaddo from NVIDIA. I'm gonna talk about the newly added application, flow performance application to DPDK. So, what's the reason of adding such application? This application is related to the generic flow API, and the generic flow API is an API that works on matching on specific ingress, egress, transfer traffic. It altered the fate of this traffic by performing some action, and also it query related counter as well. As a result, the generic flow currently is a worldwide important API, and as a result, the performance factors become very important for this. So from this point, it needs some tool to measure the factors and the performance factor of this API. So this is the reason of having flow perf. So what is flow perf? Flow perf is coming from flow performance application. Is an RTE flow related performance stats application that mainly created to do some measurement related to RTE flow, and those are the current supported are the insertion rate, deletion rate, the footprint and memory consumption for RTE flow, and also it performing some packet forwarding stats, packet per second. Okay, first of all, let's talk about how to use the application and how to define RTE flow rule structure. The application doesn't have any CMD line. It just it's simpler than this, and also it works about the application option itself. You can define the structure of the RTE flow in the options, and the application will translate this structure into RTE flow. And the difference between all these flows that inserted will be the source IP. So the application options takes the attributes, items, and actions for the needed flow structure and start performing the features that in it in order to provide the measurements. So it's good to know that the application options are user order sensitive regard items and actions. What I mean by this, for example, if we have marked in queue in the option links, the array for the RTE flow will be marked and queue. If it is queue unmarked, it will be the reverse queue unmarked. So it is very useful in cases of the in-cap, decap, and header modify actions. The application has some default values for the RTE flow. The first one is the generic flow default group. If the user didn't specify with -- group equal the group number, it will be determined as group 0, which is the default. And also the rules count per port are determined by 4 million if it is not specified in the option links. Okay, now let's start to talk about the feature in this application. First feature that we're talking about is the insertion rate. What is the insertion rate? The insertion rate is the total number of RTE flow rules that can be inserted to the hardware using DPDK in a unit of second. So the default mode for this feature and this application is enabled by default. The supported cores for this feature is currently single core insertion. It mainly translates the flow structure into RTE flow by building and filling the attribute items and actions. If you look into this the chart on the right, you see the scenarios of the flow of this feature. First of all, the application will start by reading the flow structure, for example, Ethernet, IPv4, UDP, and the action of that. It will start a timer, start building and creating RTE flow with the source IP 0. And checking each time if we reach the max rules, that it is by default 4 million and can be altered by also an option. If it is yes, we record the end timer. Otherwise, we do ++ for the source IP and create again another RTE flow. Why we do source ++ in order to make sure that all the RTE flows are different indicates from the hardware, and nothing is cached. This way, we can make sure that the millions of rules are different in the hardware, and also we can check the insertion rate. In the end, we will have the delta between the timer between before and after the insertion of the millions. Due to this, we can do some calculation in order to provide the insertion rate. This insertion rate is usually reported by kilo rules per second in the application. And one thing that it's good to know that the application here is an error blocking. What's the meaning of error blocking? The error blocking that while inserting the rules, if any rule happens to occur any error from the BMD or DPDK or anywhere else, the application will report the error and describe the status of this error, and then block. It will not continue to the other features or anything else. It will just block and exit. This is to make sure that to let the user knows that you are working on something wrong, and if the application continue, will not provide the accurate results. So this is for the first feature, the insertion rate. The second feature that provided by this application is the deletion rate. What is deletion rate? Deletion rate is the total number of RTE flow rules deleted, the deletion rate by the hardware using DPDK. The default mode for this feature in this application is disabled. So if you run the application without enabling this feature, it will just do the insertion. To enable such feature, you need to use minus deletion rate. This is an application option. The supported cores for the deletion rate currently is only single core deletion. And also, this feature is activated after insertion process is done. It destroys all the inserted rule. How it is happening, if you look at the flow at the right, you will see that after the insertion process is done and we have the deletion rate enabled, it will start the timer, start calling RTE flow destroy for all the rules until we destroy all the rules, then end the timer and report the deletion rate. And for this feature, it's also an error blocking, and any error that happens while calling RTE flow destroy will block the application, exit the application, while also reporting the error stats. So this is for the deletion rate. One more interesting feature that this application can provide is the footprint memory consumption. It is the actual memory that the RTE flow can consume from huge pages in the DPDK layer. The default mode for this feature is enabled. It happens before and after the insertion. You can also use some extra stats by using minus the socket memory. This will print stats before and after the insertion in order for any debug usage. How this feature works, it mainly starts reading the huge pages of the memory before the insertion or the whole insertion process and start in M1, and then at the end of the insertion, it also read the huge pages again and check the difference between the huge pages. The difference will represent the total huge pages consumed by for example, the default 4 million rules. So dividing this number on the memory consumption will provide you the memory per rule. So this is for memory consumption. Okay, the last feature that is provided by this application is the packet forwarding. What the packet forwarding is normally do our XTX between the packets. The default mode for this application for this feature is disabled. It is activated after all the other features are done if it is needed. How it works, it's mainly divide the queues ports into substreams. The application will read how many cores that the application can work on. It will reserve a main core for printing a real-time status, and divide the streams to available cores, exclude the main core. And then all the other cores that are not the main will start doing in infinite loop on RX to do TX for the streams that they are handling. This way, you will see a live status in this application for the rule for packet per second. This is an interesting to check the packet forwarding rate after inserting million of flow rules, and it would be more interesting if you start sending packets that actually match the inserted rule. So to enable this feature, you need to use -- enable forward, and everything should work. So those are the current features supported by the application. The application is mainly supporting almost all the items that exists currently and all the actions. Of course, we are humans, and there is something that is not there, but hopefully as soon as possible we'll have everything there. So this is mainly for the flow perf, and we can check questions for now. Yes, it was a typo, but yes. Okay. How to measure before after memory? We just calculate the socket memory itself. We check the socket memory and check it again after the insertion, in order to check the difference between the huge pages. And also, it is meant to be replaced by another library that check the system memory. It will be in the next state. Control agent. Now, currently we are it just do the insert. You can run this application on any environment that support DPDK. There is nothing specific for control or anything. If it can run there, it can run there. But it just run with PCIs, and then insert the rules and do the other measurements. Yes, it is a test tool. Something that it's interesting to see in the real life applications to check the insertion in the same time that we are sending the packet. This is something that currently the application not covering, but I think this is the real use case, and this is a bottleneck that we need to check, because when sending traffic and in the same time we are inserting rule, we need to check how everything behaves.